2 minutes, all the antivirus guys are ripping it apart and sending it out to everybody. So your PDF automatically gets flagged unless you do some crazy obfuscation to that PDF. All right? And at that point, you have to hope that their spam filters aren't doing any type of analysis to actually look at that PDF, and then you know you're screwed. Like a FireEye, for example. Right? A FireEye is going to disassemble that PDF and be like, hey, it's calling out to China. Right? I don't know why I picked China, just random. And totally random. The name of the PDF was APT1. It was just weird, but but things like FireEye are gonna pick that up. So the way I typically work is I'll send them links to click on, and then I compromise them through that because none of the web content stuff is picking up on the stuff that we're doing. So.
Are you familiar with Palisade? Palisade's new.
I'm familiar with the Palisade bowling alley.
It's a DOP solution.
Okay, gotcha.
You put it at the egress points.
Yep.
One of the things I found interesting is that they have your normal rules and hashes and everything that goes through, but then what it does is if it can't find how to get at it, so let's say an executable, it keeps looking at it, finally it says, okay, I'm going to put it into a virtual environment
Yep.
and execute to see what happens.
Yep.
No, it's Palisade is the name of the company.
I think I have heard of that, and so FireEye does similarly the same thing, virtualizes sandboxes and looks for the calls. Now, cool thing with Set is those binaries that it downloads don't do anything. Just click it, nothing happens. Like nothing. Like you could disassemble and do whatever you want to, but nothing happens until you feed it that cipher key, and then you feed it that shellcode, and then it decrypts it all, and then sends it into memory.
You're doing it separately.
Yep.
Doesn't see it as a threat. Okay.
No. But I mean, it's definitely great technology. Same thing for PDFs. That's why I don't ever send PDFs or like malicious documents or things like that. Like I haven't done that since like I got out of high school. All right. Just for the fact that like everybody picks up on it. And I guess high school's a little rigorous. It's probably the Marines, but still, it was a long time ago for me. All right, real quick, call for presenters. We are always looking for people. John Strand, Paul Asadorian, all those guys, just really great friends and people in the community that are really well known are going to be coming and speaking at the conference. So great conference. It's $150, and then there's training beforehand. So if you're interested in training, there's training as well. So it goes September 25th through the 29th. 25th and 26th is the training. 27th, 28th, and 29th is the conference. May 19th, typo, obviously, and all that good stuff. Special thanks to Hurricane Labs again for the food and TrustedSec for the
June 19th. Yes. That's a really bad. Yeah.
I'm like, not only did I typo that, but I got the wrong month. All right, sorry. It's been a long day. I haven't slept in like 2 days. All right, let's get into
Cleveland Locksport this Saturday, launch house.
Cleveland Locksport this Saturday, launch house.
12 to 4.
12 to 4.
Look us up on meetup.com.
ClevelandLocksport.com.
ClevelandLocksport.com.
What is that, though?
For people interested in learning about locks and Locksport.
So, EMET, and there's different pronunciations, I guess, for it. I say EMET, but it's the Enhanced Mitigation Experience Toolkit. Has anybody actually used it before? I know we had a couple folks in here, but EMET is was version 3, then 3.5 came out, and then right now it's beta 4. It's supposed to be, I think, May 28th. The full version is coming out, and I think the only major differences between the beta to now is there were some issues with some blue screening with a certain variable flag set, but if you actually edit the registry key, you can remove that unsafe check. But sometimes it would blue screen when you boot up. So I think that's what they're trying to fix in the latest version, but not sure. And essentially, EMET is designed to stop a lot of the 0 days that you see out there today. And why I say that is I'm an exploit researcher, so I've built 0 days, I've fuzzed, I've done different types of exploits. I wrote a paper on return-oriented programming before return-oriented programming was even out. I didn't even know what ROP was at the time. And I'm very, very good on that side, and I'm maybe not as much anymore. I do mostly in the social engineering side. But with EMET, it has a lot of mitigation strategies that attackers use to try to compromise a machine. So you might have heard of words like buffer overflows, or integer overflows, or use after freeze, or heap overflows, or heap exploits, right? Or return-oriented programming or ROP type attacks. Okay, these are all common techniques that hackers use to find an exploit. Now, let's just do a quick introduction of what an exploit is, and I'll give you a very, very basic introductory lesson to that, what an exploit is. Okay, so let's just take a a 2001 FTP exploit, just to make it really simple because it's gotten much harder since then. When the programmer designs an application, he says that this username field and this password field will accept 5,000 characters. Okay? What happens if someone puts in 5001? Anybody know?
Depends on what the code is.
Well, it depends what the code is, right? If they put proper checks in place, nothing should happen, right? Just spit back and say, you went above 5,000 characters, something's wrong. However, if they didn't, then the application crashes, all right? And what happens is when that application crashes, if you send a bunch of data over it, you can manipulate the stack, which is typically a stack-based overflow, to get code execution to get to your code, okay? Now, that technique alone was traditional stack-based overflows, all right? So you would overwrite some code in your stack, you'd then figure out a way to get back to your code, and then you'd execute it, typically a jump or something like that. Now, they came up with a technique called data execution prevention. Now, what data execution prevention did is it marked that stack read-only. So when I execute this code, or I overwrite all this code and I jump to my code, I can't execute it because it's read-only. All right, so it makes it much more difficult for me as an attacker. Now, there's ways of bypassing that. The main method today is return-oriented programming, or ROP. ROP allows you to basically think of it as a big puzzle. It's a big game. You're basically going into memory, picking up pieces that you want of your code to get it so that you can remove either data execution prevention or copy it somewhere where you need it to. So you're going over here, you're grabbing a little code here, you're returning. You're going over here, you're grabbing some code, you're returning. You're grabbing over here, you're grabbing some code, returning. You build your puzzle, which is called your ROP gadget, and all of a sudden you execute it, or you don't execute it, but you use it, and then it then takes your shellcode and you can execute it, okay? So there's a lot of different techniques out there. Heap, for example, has anybody noticed when you run a Internet Explorer exploit, your machine gets real sluggish and slow? Anybody know why? I know you know why, but. So what happens in heap exploitation is the heap is just considered like garbage memory. Okay, it's stuff that's dynamically allocated and deconstructed, really fast. So say you're browsing a website, you go to like Google. All that stuff to load the images, all that stuff is basically stored in the heap. So all your basically temporary data is in the heap itself. Now the heap is just random memory addresses, stuff everywhere. There's a bunch of stuff that you can't get a reliable exploit in. And so a guy by the name of Scapey back in I think 2006 or 2007 came up with a technique called heap spraying. And what heap spraying does is it allows you to grow the heap so large that with what are called NOPs and your shellcode, which is your exploit code, and you grow it so large that when you jump somewhere in randomly into memory, it rides this slide down, and you're sliding down a bunch of nothing, and you hit your shellcode and it executes. And that's why your computer gets so sluggish, because it continues to grow your memory. Your memory actually fills up. All of your RAM fills up until it's full. You jump somewhere in memory, you ride down this slide in memory, and you execute this code. Okay? So different techniques, all right? There's a whole bunch of them. Now, what EMET is designed to do is try to stop a lot of these different type of techniques that are used, i.e. heap spraying, stack overflows, most specifically data execution prevention and always on, ROP mitigation techniques. There's a lot of different techniques that are built into this, and it's a really cool tool, nifty tool for Microsoft. And I'll get into some of that. So it has the ability to detect ROP, and the reason it does that is it actually analyzes what's happening and looks for a bunch of returns. And if it uses a significant amount of returns, it knows that it's using a ROP gadget and it actually disables it. Heap overflow attacks, buffer overflows, integer overflows, whatever you name it, it has a really good capability of actually stopping. And the best part about it all is it's free. So you don't have to pay for it. You don't have to use your EA licensing for it. It's free. 100% you download it. It's good to go. And here's some of the features, and these are some of the most notable ones. There's a ton of them. My favorite is the load library checks. So basically, when you load different libraries, a common technique would be to use a UNC path to get your code or to get something to download. Prevents against that. Also does the caller checks for return memory instructions, looking for those for ROP gadgets. It actually simulates execution flow, looking for the ROP gadgets to see if it actually works. Stack pivots, pivoting to different stacks. Like a lot of times, what I use, what Metasploit uses a lot too, is like virtual alloc to allocate memory to another process, and then you inject your stuff into that process and then deconstruct your other process. Actually stops against things like virtual alloc and things like that, and it's actually embedded into the kernel to monitor that. Anti-detours, ban functions, like functions that are notoriously known as being bad from an attacker standpoint, it actually does a lot of those. So it actually has some pretty extensive capabilities built into it to actually protect against a lot of these. And I actually spent about the last week or so really trying to dive down into EMET, understanding what it does. And it's extremely difficult to get around from an exploit perspective. Extremely difficult. It's bypassable in some senses. There's actually some old bypasses from 3.5 that they actually fixed a lot of. So I think Scapey accidentally posted a blog post on how to bypass EMET, and then he removed it, but Google cached it, so he still had it. And so there's some bypasses out there for 3.5, but 4 actually fixes a lot of those. So really good stuff out there, really hard to do. And actually show you just a quick demo real quick here. Where are we at? So I'm just going to show you just a real simple debugger, and for those of you that are exploit researchers like Doug, it's going to look pretty basic for you. Sorry, bro. So I'm just going to open up an executable. So this is what's happening in your computer, real time, in the background, in assembly code, okay? And this is a debugger. This is what's happening in memory, all right? So memory is allocating things. It has counters. It's making calculations. It's actually integrating with your RAM and everything else, and it's doing all your stuff, right? Now, this is what we call the stack. Over here on the right is what we call registers. And registers have different functions. One of the biggest registers that attackers typically use in traditional overwrites is EIP. And EIP is the instruction pointer. It basically says, once you finish with this stack, where do I go next? Okay? And so when I do an overflow, and I say I overwrite all this here, eventually I'm going to get down further enough in the stack to overwrite EIP. I figure out where that's at. I rewrite it with a different memory address that typically says jump ESP, starter pointer. It goes back to our code, and then it executes. All right? That doesn't work in traditional data execution prevention type modes. And Windows Server 2003 Service Pack 2 and above incorporates data execution prevention by default. But what's nice about the way EMET structures it is it configures your machine to do what's called data execution prevention always in, which makes it much more difficult to circumvent and bypass. Still bypassable, but not without ROP. Not to blow your minds there, sorry. So installation procedures, it's extremely easy. You just take the EMET installation file, the 4.0 file, and with 4.0, and I think it actually was in 3.5 if I'm correct, but they actually give you group policy extensions so you can actually add to your Active Directory group policy to configure EMET through there as well. So I think it's under the deployment folder / group policy. You have the ASAL and the ASMH files that you can import into group policy, and you can essentially manage EMET from a group policy perspective. So you just take your MSI file, deploy it with the configurations and XML files, deploy it to your entire company, have it all centrally managed through group policy, which is awesome. Huge step. So again, it's on beta right now. I have it running beta on our entire production instances, which is kind of how I roll with things. But the real version is supposed to be May 28th. I haven't had any issues at all with it. Download link, if you just Google EMET download, you'll find the latest version there. So first thing you do is you just download the MSI, you double click it, you run it, you install it, good, all set. Then you go to your start menu and you have an EMET icon there. And this is what it's going to look like when you open it. It's look a little bit different. This is fully configured. But essentially this is your window that you deal with. And I'm actually going to show you installing it real time here. But essentially what you do here is go to here, configure some stuff, go to your policies, either customize the XML stuff, we'll get to that in a second. But ultimately what you're looking at here, here's some of the four key underpinnings of what EMET will do. First is the data execution prevention always on, which is important, right? Structure exception handler overwrite protection. Now, there's exploits that are called SEH overwrites, structure exception handler overwrites. And what happens is, anybody ever seen an application that says this program has crashed, hit close to close it gracefully? That's what we call a structure exception handler. And so when they compile the code, they compile it with the structure exception handler code. Was it /SEH compile flag? And so what attackers can do in that type of instance is they can actually overwrite a certain portion of the SEH, jump past it, and then jump before, usually in most cases, so you jump over the next, and then you have your next SEH, and then you execute your shellcode. All right. What this does is it puts safe SEH on, and it has protection around SEH overwrites to not allow you to do that. So it actually stops that common attack method, which is really cool. ASLR, Address Space Layout Randomization, is one of the coolest ones I think that has ever been implemented. I think Linux has actually been doing it since like 2000, but ASLR is a really cool technology. And what happens is, remember I showed you that just a quick, when I overwrote EIP, or you can see EIP and typically hackers overwrite that. What happens is, every time you reboot, Microsoft randomizes the last 2 bytes or 4 bytes?
4 bytes.
4 bytes, yeah, it's 4 byte overwrite. So they randomize the last 4 bytes of the memory addresses. So what happens is, as an attacker, we typically, as an exploit researcher, you try to find specific hard-coded memory addresses that you can use for your exploit, because you have to call certain pieces, especially in like ROP gadgets. You have to, assemble some code here, assemble some code here, assemble some code here. You have to know where those are at. Now, if it randomizes every time, you don't know where they're at, right? So therefore, you can't make a reliable exploit. Now, there's ways of bypassing it with partial overwrites or doing other types of exploit techniques. But essentially, ASLR makes it much more difficult for you to be able to exploit it. Now, certificate trust pinning actually verifies the certificate itself when it actually runs, so making sure that the certificate itself is valid on the machine. I believe. I could be wrong on that.
What does it base that on? Is it based on
Valid cert on, I think, the Microsoft CRL stuff. So it actually looks for the actual certificate path for that. And again, I could be wrong on that. I haven't investigated that as much versus the other three options, which I typically work for. When you click on, and just show you, when you click on this button here, this Configure Systems, again, we just installed it. This is brand new, fresh in the machine. You click Configure Systems, and what this does is it gives you the ability to customize the settings here. I typically recommend the maximum security settings. Now, people get freaked out by that because you might think it might put more additional restrictions on. I've never seen any type of crashes or performance impact hits. Have you? Yeah, I mean, I've deployed it, on a number of systems. Never seen an issue with maximum security. And all that's saying is protect all the processes that are Microsoft owned with the type of protection mechanisms that you have in place. And we'll get to protecting the other processes here in a second. So I always do maximum security. And next, we want to configure the policies. Now, the policies, there's two ways of doing this. One is through the GUI and one's the command line. I always opt to go to the command line just because of street cred. But what happens with the policies is they allow you to import an XML file. And there's predefined XML files that Microsoft has. There used to be one in 3.0 and 3.5 called all.xml, which I used to use all the time. They got rid of that, and they changed it to recommended software, which is more of the robust one. And that includes things like Adobe, Java, 7-zip, all the common software packages out there. And what it's looking for are executables. So here's where you actually need to configure things, okay? Take your base images that you deploy to your company, and the type of software that you deploy on it, you actually have to specify where the executable paths are at for those executables in order to protect them. Right? That's important. It actually requires some configuration, right? But at least you can clip the majority of the ones that are going to be the 0 days, right? Like Java, Adobe, those are out of the box default in the XML file. But when you import this, what happens is it lists all of those executables to be protected. And what it does is it imports the protection DLLs to then give you that support that you need with ASLR, data execution prevention, SEH, overwrites, rot mitigation. That all gets imported into that executable. So let's just say the latest Java 0 day comes out, right? And it's an exploit, okay? So it's not going to always protect you against Java 0 days. Like the sandbox breakouts, that actually takes into account implementation flaws of Java, not an actual exploit. It won't defend against because it's not an actual traditional exploit, right? It's not like someone's writing a heap overflow or things like that, but it will stop against traditional exploits, like someone wrote an exploit for a specific thing. So like the Rhino attack that came out with Java 7, it would not have stopped that because that's the sandbox escape. However, it would have stopped a lot of the common attack vectors, the common exploits out there. So you can either import the default one there, or when you have a base image of things that you install, especially on servers, just give it the path and the XML files, and you just configure the XML files, the protections you need for them. The XML file is pretty well documented, and the actual instruction guideline that comes with EMET tells you pretty good on how to do that as well. But essentially, you go to program files, EMET4.0, you go to emetconf.exe, you -- import, and then you go to the deployment folder, which inside the deployment folder is where the group policy plugins are at. But also the protection profiles are here. You just specify recommended software.xml. You then import that in, and now all of a sudden you're all set. And that alone does not require a restart. It might require a restart of the process to get the protections in, but does not require you to do a restart. However, when you specify the maximum security settings that you just saw before, it will require you to restart the machine itself. Okay?
Does it allow you to put in a hash for the executables, or is it just strictly a hash?
I don't know. I think it's straight to just the path. It's the path. Yeah. No, it's straight to the path. It doesn't do any type of hash or anything like that. With things like App Locker, for example, in group policy, which is kind of Microsoft's whitelisting, blacklisting, that allows you to specify hashes if you want to there. Here's the advanced options. Here's just some additional configurations. If you do the maximum settings, this will automatically be configured for you. But basically, this is a lot of the stuff like the rot mitigation techniques around detours, ban functions, and deep hooks. So deep hooks are embedding itself into like low levels of the kernel. Supported operating systems: Windows XP Service Pack 3, Windows Vista Service Pack 1, Windows 7 All Service Packs, Windows 8. Windows Server 2003 Service Pack 1 and above, Windows Server 2008 and all service packs, Windows 2008 R2 all service packs, and Windows Server 2008. So pretty much any newer operating system, Windows XP Service Pack 3 and above, it will support. And this is, again, for version 4. Version 3.5 does not support Server 2012. So if you're running a 2012 instance, it will not support it. Although I have it configured. I've had 3.0 on Server 2012, and I haven't had any issues, but still. Now I'll show you a quick installation here. So we're just going to install it, default everything. I agree. Yes. All right, close. And we go to our menu, look for EMET, right here. Yes. And we get to this configuration here, right? And this is what it'll look like when you first configure it out of the box. First thing we're going to do is going to go to Configure Systems, and we're going to do the maximum settings. Now notice here I have one of my previous payloads on there. I'm going to stop that real quick. Yeah. 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 There's a I like once I got used to it, like I hated Windows 8 with a passion at first. But once I got used to it, I actually started to like it a lot. And to be honest with you, me using Windows 8 for a little bit, just for like exploiting, helped me out when I actually started loading it for Server 2012 for my domain infrastructure at work. So it helped out a lot. All right, so we're going to go to Configure System, go to Maximum Security Settings, always on, hit OK. Now it's going to say, are you sure you want to do this and want to use ASLR on all the time? Yes, sure, sounds good. It'll be fine. It's fine, don't worry. I've never seen it have any issues. Except I was rebuilding Exchange 2 days ago for some reason. I don't know why yet, but that was horrible. I haven't had any issues. I have it deployed on web servers, no problem. Web servers, huh? Yeah. Yeah. I haven't had any issues with Apache either. Although I don't use much Apache, but I haven't seen any issues in Apache. No. So notice it says the changes you have will require a restart. Cool. We're not going to restart yet. Don't do it yet. Now here's where we can import the actual processes. We can go to Import Settings here. If we don't want to do the command line, go to Import Settings, and then you have the 4 ones that are published by Microsoft. I definitely recommend creating your own XML file that is specialized to your server infrastructure, that has your software on it, because ultimately at the end of the day, that's going to be important. Like, for example, a lot of ways that we break in are through outdated third-party software, like Veritas or Symantec stuff, Symantec System Center, or whatever that thing is. The Management Console is always a good one. Just out-of-date stuff that we always forget about as sysadmins, and you have this protection on there. My exploit is not going to work. My direct, maybe it won't. I mean, good chance it won't if it's a standard exploit, right? So we import recommended software. Now notice here, if we go to Configure and we go to Applications, I should have showed you this before, but none of this was here before. And here we have all the different, all the Microsoft Office stuff, Adobe, Java. I don't see Java on there. That's interesting. Oh, there it is.
Why is there 3 or 4 or 5?
Just different paths. What's that? Yeah. Yeah. So you could definitely remove them all and put them on with your XML file. That's great. Over here, notice a couple of here, like Excel, for example, don't have DEP and SEH protection on. You can always just hit Enable for all applications in these areas here. So you have different features and functionalities you can do. Why didn't that go? That's weird. There we go. So it's pretty easy to configure, pretty easy to expand. Memory protection, route mitigation. Notice all of those are all part of the protection mechanisms that you import in with that XML file. I mean, real simple, right? Not hard to do. Again, with group policy management especially, I mean, you're talking being able to deploy to an entire corporation with minimum notice. I mean, this doesn't pop up and warn you in certain instances. Obviously, you need a test. Here's the advanced configurations. Again, if you did maximum security, what will happen is if it detects the attack, it'll actually stop the program. It'll actually stop the program from actually running itself, which is good. That's what you want. Halt or audit only. Yeah. So. Yep. Group policy. Yep. Yep. Yeah, this rocks.
So that would make every exploit a denial of service. Oh.
Yeah, possibly. I'd rather have it denial of service than owned. Yeah. But I mean, so true, yes, depending on the exploit. Okay, so if an exploit's detected in a threaded process, it's not going to shut down an entire process tree. It's not going to shut down the parent. It'll shut down that child process. Like for example, let's just say EMET2 If I use EMET2 and I target, you know, SMB, or whatever, RPC. There we go. Thank you. Weird. Like that's the one that's the pinnacle exploit for us hackers. Like we have birthday parties for EMET2 and I couldn't remember it was RPC. It's weird. But say I trigger that exploit and I have you know, EMET on it, it wouldn't crash the service itself. The service itself should still be running. RPC should still be running. But more other applications like potentially like single-threaded processes could potentially have that. Good question.
Where does this not work well? Like, what does it break?
I haven't seen it break anything unless you've seen. What's that?
I've seen
Some
some DBA stuff.
DBA stuff like Oracle.
Just Visual Basic.
Oh, Visual Basic.
Like a little VBA app or something.
Oh, okay.
I
Yeah.
haven't seen that. I have to see a process that work with it actually.
Yeah, I haven't seen.
Check that until you find out when that broke.
Yeah, yeah.
So if it's this good, why can't you like have it do all processes? You have to what? You have to
Well, the way that it works is through finding executables, and that's why the all one was cool because the all one would actually go through and add all of your executables inside your directory structure. They haven't added that. I'm sure you can add all to it as well.
You can add them through the integration.
Yeah.
You
Yeah.
export them on XML and modify it.
Yep. Yep. So there's different ways of adding them too. It's just that's kind of how they wrote it. But again, it's super easy to configure. And let me show you. Let me see if I'm still connected to my VPN here real quick. Yeah. Yep. Yeah. So using like the recommended software and then adding your own, you know, XML part onto it. That's definitely what I would recommend.
Is there easy ways to pen tester to know when EMET's active?
Not that I know of.
Face palming over and over again, trying to
I think
figure out why you're-
experts talk.
So here's, you know, EMET running on a the lag is killing me on the passwords when I type too fast. So here's EMET running on a server 2012 instance, fully patched, and it's running great. I have it on deployed on all my servers at TrustedSec, so it works out really well. Yeah, yeah, on the application list.
On the column over on the right.
Oh wait, it's yeah, should be. I'm on max settings and I have applications configured. Come on. Yeah. How much work does it take? Not much. Yeah, I haven't seen any much on the performances. I mean, it's a small DLL that gets imported.
Oh, it's just
Yeah, it's tiny. Yeah, just hooks in.
you,
Yeah. Go ahead.
recommend this on servers or taking together to make it closer everywhere?
I personally want to put it on everywhere. I mean, my personal opinion, especially from the user populations that are just getting owned left and right nowadays. I keep it on the server population too. I mean, definitely, I would recommend both. I mean, I'd probably gradually first start off with the server infrastructure, just to get kind of your feet wet, and that's kind of your area of jurisdiction, the most part, and then deploying it slowly out to the user population and testing it out. Yeah.
Can you manage it by PowerShell?
I don't know. I don't think so. I don't think so. I haven't seen any EMET PowerShell stuff. Could be wrong.
That would be a way to, because you still should be able to execute PowerShell still.
Yeah, you should. Should. Anybody have any questions?
So speaking of PowerShell, that little shortcut that you have to PowerShell,
Well, the problem is I'm not using any standard type of exploit, so no, it wouldn't stop against that. But you're talking, I would have to have post-exploitation on the machine itself. So I'd have to have access to the machine itself. So it won't stop against the payload delivery now. Although it does have virtual alloc protection. That's one of the calls I use for injecting the shellcode in there. So it potentially could. I should test it out and see. That's a good idea. I'll test it out. Any other questions? Well, thank everybody for coming to NEOISF. Hope you really enjoyed the beer and the talk. If you have any questions, always just feel free to email me anytime. I'm always happy to help. If I don't respond right away, just send me an email again. You never know me. And then also I have trusted sec wristbands that glow in the dark. Again, they're really good for parties. So you feel free to come pick up one. Have a good one. I'll see you next month.
Yeah.